box. Yeah, a box. Do it on the very right. It's not going to be a very big box. Something like that. Okay, that's the worst box I've ever drawn. Let me cheat and use a predetermined shape. Okay, so everyone draw your little box here on the very, very right. And you're going to put this box on the ground. So everyone drawing the ground in a box. Drawing a box. Draw a box on the very right next to all the parentheses. Draw a box from here. And good. So this box is getting dragged. It's being dragged by a person, and that person is taller than the box. So it's like drawing a diagonal. Now the force that's pulling this box is 130. So everyone write 130. Let's write that better. Like Google drawing. Okay, so it's 130. And then the angle is 33. So you have to imagine that there is a line that is 33 degrees. There. If I can just get this drawn. Save. 3. I gotta zoom in. It's just not working with me. $33. Okay, I'm just gonna copy it. I don't know why I can't write 33, but we'll make it work. There's always a way. And that's 33 degrees. Tiny little circle here. All right. So a person's dragging a box at a 33-degree angle, but the box is not being lifted up. So you don't even have to think about the force going vertical. You only have to try to imagine the force going sideways. So what is the sideways force acting on this box? We have to use geometry or trigonometry. So what is the angle, Jesus, that the box is being pulled at? 33. So that's what we put here for cosine. Everyone put 33 cosine. And then we have to put the hypotenuse into this equation. What's the force being pulled on the box, Jimenez? 130. So now all we got to do is solve for the adjacent of the box. This force down here is A. And then that'll give us the force that we put into our work equation. So grab a calculator, and Jimenez put cosine 33 equals. What do you get? 8.39 e to the negative 1. But instead of rewriting that, because we run out of room, I want you to multiply all that by 130. Because that's how we're going to solve for A, which is the horizontal force being pulled on the box. What do you get? 1.09. Yeah, it would be a 10 if there was like a 5 next to the 9. But we're going to just keep it as it is. And is there an exponent? 2. Okay, so this first step is finding the force moving sideways. Who cares about the force moving up? Because the box stays on the ground. Now we're going to put this into our work formula, multiply it by distance, and this gives us the work the person's doing. Remember, work is only if the object's moving. If the object's stuck, it doesn't matter how tired the person gets. In physics, it doesn't count as work. This is 1.09, E2. This is the study guide. Practice problem. Did you check with the answer key? And they're all good? All right. Here's student number 3. Here you go. All right. Let's move our force into the work equation. And put in the distance. So, Devin, what's the distance the crate has moved according to this problem? That's the force. We've already used force. What's the distance? 45 meters. So we put 1.09 E2 times 45. Grab a calculator and put that in, Devin. 1.09 E2 times 45. That is a 45, yes. Make it a little better, but that 5 is hard to do on a computer. The what? No, this is a one-step problem, so you can just multiply. I got 5. Try one more time. 1.09 E2 times 45. 45. 4.9, and then what will the 0 become? Good. And then what's the rest? Good. E3. If I could just draw 3. There. So that's the work the person's doing. We also have to find how much work friction does. Because if you drag something on the floor, usually there's something resisting you. So how do we find the work of the friction? It's the same thing as finding work of a person, force times distance. So, Shauna, what is the force of friction in our problem? 65 newtons. So put in 65 in this parentheses. And then what's the distance the box is traveling? Devin said it earlier. How far did the box travel? That's work. What's the problem telling us is the distance. 45. And one way to tell is if there's an M next to it. That's like meters. Meters is always distance. All right, Sean, grab a calculator. Put 65 times 45. Good. He rounded. And E3. That's the parentheses. Let me get my 3 down. Okay, so if you've got 4.91 E3 going to the right and 2.93 E3 to the left, what's left over? That's called net. When you subtract two things like that. So let's plug that in. Work of the person is 4.91 E to the 3. I don't know why I'm writing worse and worse, but this, maybe I need to restart my computer. But this is our last problem. 4.93 E minus 2.993. I'm just going to copy paste it over. It's just so hard to read. But I'm just moving over the work of the friction to this work of the person. Do this. Delete that. It's minus. Delete this. Put that over here. And Demore, do the subtraction. You did it already? Good job. 4.9391 e to the third minus 2.93 e to the third. You get 1.98 e to the third, just like he said. And that's how much work is done on the box with friction. All right, well done. All right, I'm going to give all 6 of you a little ticket, a prize with Miss Jackson. Where did I put my tickets? Here they are. Just for improving. You guys improved yourselves. So this is Lim. You'll have to write your own name, but I'm sure she's going to give you something worth your time and effort. Okay, so this is most improved. There you go. Give this to Demore. That's for you.